We just went through the perimeter of this object. Now we're going to focus on the area of the object. And again, this is a composite figure, so it's a figure built up of other shapes. Now in this case, we can see that we have two triangles. Oh, that was an accident. We have two triangles and a rectangle. This is also known as what? The greater shape. Trapezoid. So what we'll do is I'll go through this solving our triangles and our rectangle, put it together, and then I'll give us the formula for area of a trapezoid, and I'll explain how that formula works. So this is going to take a bit of time. First off, let's number and call each of these something. So this will be triangle 1. So if I'm going to find the area of triangle 1, and I'll highlight it, triangle 1 will be in yellow. Okay. The area is all of the space that it takes up. So we're going to call this area of T1. Okay, that's how I'm going to define this. The second triangle will T2, just like the Terminator movies, right? Call this the area of T2. The highlighting didn't go very well. And the rest of the space will be our rectangle. I don't know where you get an H. I think it's still A, guys, because we're finding the area. And if it's a rectangle, we usually... I wonder if that's on there. Area of the rectangle. So, in order to figure out this, the total area, okay, so total area is equal to, and I've called each of these something. So the total area is equal to the area of T1, so I'm going to call it A T1, so the area of triangle 1, plus the area of triangle 2, plus the area of the rectangle. Okay. So in other words, what we're going to have to do is we're going to have to solve each of these individually and then put them together into this formula to find the total area. So we'll start from left to right. We're going to find the area of T1. Does anyone remember the formula for the area of a triangle, Hervé? That's right. So AT1 is equal to base times height divided by 2. And the other day we talked about why we divide by 2. Base times height finds a square, and we split it in half. So what is the base of this triangle? 12. That's right. And what is the height? 16. What if I called the base 16 and the height 12? Would that work?
No.
Yeah, it would. It would still work. It would make no difference because it's a right-angled triangle. Okay, and that's very specific. It's because it's a right-angled triangle that would work. So our base, like we said, was 12. We'll have to multiply it by the height that was 16. And we'll divide it by 2. So it's the same as 6. What is it, 96?
Can you put
Beautiful. Hold on a second. 96 centimeters square. That's right. Because we're working with 2 dimensions now, we have square. Second thing we need to figure out is the area of triangle 2. Still start with the exact same formula, base, and I'm going to write it a little differently. Base times height multiplied by a half. This is still the exact same formula. When I multiply something by a half, it's the same as dividing it by 2. This guy's back there. So, what's the base of this triangle? 4. What's the height?
16.
Excellent, okay? Because these two are the same, we know this is 16, so we're going to be multiplying the numbers 4 and 16 together. So I'm going to take 1/2, multiply it by 4, and then multiply it by 16, which should be 32?
Yeah.
32 centimeters squared. And finally, the area of our rectangle. What is the formula for area of a rectangle? Very simple. Length times width or base times height, they're representing the same things. And what are the values for that in this?
24.
24 and
16.
Good. So 24 times 16, what do we get, Scott? 384? 384 centimeters squared. Okay, so to find total area, we said we had to add all of these together, right? So our total is equal to our 96 plus our 32. Just ignore it, I'll get rid of it in a sec. Plus 384. What is the total area of this object? 512? Excellent. So, we did that by getting the area of our two triangles and a rectangle. The next thing I would like to do is I want to show you the area of a trapezoid formula. Okay? So, area, I guess I'll call it TR so it doesn't look like triangle. Okay. Area of a trapezoid is A plus B, that's right, times the height divided by 2. And I know that, I'll go into this, what these stand for. Okay. So, of our trapezoid above, I'm going to make a rough sketch of it. Sorry, I need one other thing. Height. Height is very important. Okay. So A and B refer to either the top and the bottom of the trapezoid. So I can call this A, or the bottom A, or I can call this B and the top B. It doesn't matter. So I've just labeled them one A and one of them B. The height is the distance across this object. So the A and B must be the parallel sides of the trapezoid. Okay? We cannot call this and this A and B because they're not parallel for this formula. The height is the distance between the two parallel lines. So the distance between the two parallel lines is our height. And once we have those measurements, we can figure out the area of a trapezoid. And what it does is it asks us to add these two together, multiply by the height, and divide by 2. Okay? Now, what I'm going to do is kind of show you the reasoning behind that, just like we had done with our, what's it called? Our triangle. So, when we add A and B together, really what we're doing is we're taking B and A, so we're extending this line. I'm going to show you what that looks hypothetically. The extended line. Oh, is that off the screen? Sorry, give me 1 second. Okay, so I've added now A and B. So here's our B and our A. We've added them together, and then it says we're multiplying by the height. Okay, so this being the height here, we're going to multiply by this, which is very similar to finding if this was a giant rectangle, right? If I multiply this by this, I'm finding the area of everything here. Okay? But I want to show you, once we divide it in half, is because this missing part here is equal to this trapezoid here. Okay? Now this might get a little confusing at this part, so I'm going to change the colors to hopefully help us out. So, remember, if we multiply the height by these, we'll be looking at the total. And what we're going to figure out, and I'm going to fix this, we said if we multiply, we find the area of this red space. Okay, so what I'm going to do is show you that that is essentially doubling this. So this triangle here, this is part of our trapezoid. That fills out this red space here. Okay, and the rest of this trapezoid here fills out our missing space. So, the reason we divide it by 2, because it's actually, if we multiply our A, so A plus B times our height, we're finding the area of double of this trapezoid. That's why we have to divide it by 2. Very similar to with triangles, why we had to divide it by 2. So, let's go up to the very top, which would be our A and B. What would be A? 24. What's our B? Do you guys remember? No, it's not 24. Yeah, we have to add them all together, and it was 40 we had figured out in the other question, right? So the B in this case is 40. And what is our height? 16. So let's go to the bottom and put it into our trapezoid formula. Our A was 24. Our B was 40, the entire distance of the base. And the height was 16. And we divide that value by 2. You're right, it is going to be 512. Let's work it all out together here. 24 and 40 is 64, good. What's 64 times 16? 1,024. And that divided by 2 is? 512. 512. When we did it by a composite figure, what did we get? We got 512. So whether I added them all together, so I took the rectangle and the two triangles, or I used it as a trapezoid, I found the exact same area.